Yes, in this video we will discuss different problems. A load of 1.5 kilonewton resting on an inclined rough plane can be moved up the plane by a force of 2 kilonewton applied horizontally or by a force 1.25 kilonewton applied parallel to the plane. Find the inclination of the plane and the coefficient of friction. Find the inclination of the plane and the coefficient of friction. Right? We have to find alpha and mu. So, this is what we want, right. So, two different cases are there. One is it is an inclined plane and the force is acting parallel to the plane and the force is acting horizontally. So, two cases are there. The first case, horizontal force, and this is the inclined plane alpha. The alpha we do not know, that we have to find. This is the block, right, and the weight of the block is always acting downward, which is 1.5 kilonewton, right, and the reaction force is acting upward, which is perpendicular to the plane, and this is R n, which is equal to R 1. Okay. Now, the force, first case, the force is acting horizontally, right. This is the horizontal force 2 kilonewton. This is the case 1, right, and now case 2. The same inclination of the inclined plane, which is alpha, we do not know, that we have to calculate, and this is the block, and the same block, the weight of the block which is acting downward, which is equal to 1.5 kilonewton, and the R n, reaction force, is acting upward, which is perpendicular to the plane, inclined plane. This is R 2, and now the force is applied parallel to the plane, which is 1.25 kilonewton. So, this is case 2, right. So, we know that separate formulas for these two cases. The force, the block is in the inclined plane and the force is acting horizontally, then the primary formula P, which is equal to W tan alpha plus phi. This is the primary formula for this case, and now in the inclined plane the force is acting parallel to the plane, then a primary formula which is equal to W into sin alpha plus phi divided by cos phi. So, this is the two different primary formulas for two different cases, right. Now, we know that P, which is equal to 2 applied force 2 kilonewton, which is equal to W, which is weight of the body 1.5 kilonewton, and tan alpha plus phi we do not know, right, clear. And now, here P, which is equal to 1.25, which is equal to W, which is equal to 1.5 into sin of alpha plus phi we do not know, divided by cos of phi, right. So, here tan alpha plus phi, which is equal to 2 divided by 1.5. So, tan alpha, which is equal tan alpha plus phi, which is equal to, so what is the value? Tan alpha plus phi, which is equal to 2 divided by 1.5, which is equal to 1.333. 1.333. So, now alpha plus phi, which is equal to tan inverse of this value, right. So, tan inverse of 1.333, then which is equal to 53.1, right, 53.1 degree. This is the alpha plus phi value. Substitute this alpha plus phi value in this equation, right. So, now 1.25, which is equal to 1.5 into sin of 53.1 degree divided by cos phi. Here we need to calculate this value cos phi, right. Now, 1.25 which is equal to sin of 53.1 into 1.5, which is equal to 1.2, right. So, 1.2 divided by denominator cos phi. We want cos phi. So, cos phi, which is equal to 1.2 divided by 1.25, which is equal to 0.96. Now, phi, which is equal to 16.3 degree, right. we know that alpha plus 5 which is equal to 53.1 degree. Now, substitute this value here. So, alpha which is equal to 53.1 degree minus 5 which is equal to 16.3 degree. Now, alpha which is equal to what is the value? 36.8 degree, right. Now, we got the inclination of the plane alpha. Now, we know that the primary formula tan phi which is equal to mu, right. So, from this equation we can calculate mu, right. So, tan of 16.3 degree which is equal to mu. So, mu which is equal to what is the value? 0.292, clear. Now, alpha which is equal to 36.8 degree and mu which is equal to 0.292. This is the answer, right. The next problem, a spherical ball of weight 50 Newton is suspended vertically by a string 500 mm long, right. So, this is the fixed plane and the ball which is 50 Newton and suspended vertically, and this is suspended vertically, right. The length which is equal to 500 mm, right. Find the magnitude and direction of the least force which can be hold the ball 100 mm above. So, this is 0 and from this which is 100 mm, right. This is 100 mm. So, this is the ball and this is the string, right. Now, find the tension in the string at that point, right. Now, the force is acting perpendicular to this which is F, right. So, this is the angle with respect to force and the string which is equal to 90 degree. This is theta, we do not know, right, and the distance which is 100 mm, right. Now, this is the weight of the ball is acting downward, right. So, this is the ball and the weight of the ball is acting downward, right, which is 50 Newton here, right. The ball is acting downward, weight of the ball W, right, and F is this is the direction of the string, right, and the force is acting, this is the force, and here the tension is there, tension T, right. So, the angle between this tension and F which is equal to 90 degree, this case this is tension and this is force and this is weight. So, this is 90 degree, right, this is 90 degree, right, and this theta we do not know from this axis, this is theta, right, clear. Now, what is draw a horizontal line here and what is the angle which is equal to 90 degree. So, remaining this is which is equal to theta, right, clear. So, now take triangle, this is 40 mm, right. So, draw a horizontal line because this is 100 mm. So, 500 minus 100 which is equal to 40. So, length of this which is equal to 400 mm, right. So, 40 centimeter, right, or 400 mm whatever it may be, right, and this is x we do not know, this value we do not know, right, and this is theta, and what is the value of this which is equal to 50 centimeter or 500 mm, right. Now, cos theta which is equal to 40 divided by 50 which is equal to what is the value? 40 divided by 50, 40 divided by 50 which is equal to 0.8, right, 0.8. Now, cos theta which is equal to 0.8, then theta which is equal to what is the value? 36.86 degree, right, the theta which is equal to 36.8 degree, then this is which is equal to 36.86 degree, right. So, the included angle or the angle between the force and weight, which is equal to 90 plus 36.86, right, and the included angle between tension and force, which is equal to 90 degree. Now the included angle between tension and weight, this angle, which is equal to how much? 90 plus 36.86 plus 90 minus 360, right. So 360 degree minus 90, this angle, and plus theta 36.86 degree and plus one more 90 degree. Clear? So how much? This value, which is equal to how much? 143.14 degree. 143.14 degree, right. Now apply Lame's theorem, because three forces are there, right. So Lame's theorem, what is the value? Opposite, I mean 50 Newton, 50 divided by sine of the included angle between tension and force, 90 degree. Clear? And which is equal to tension T divided by the included angle between, the sine of included angle between weight and force, which is equal to 90 plus 36.86, which is equal to sine of how much? 126.86 degree, which is equal to now force F, which is equal to F divided by sine of the included angle between tension and weight, which is 143.14. So sine of 143.14 degree. So this is the method of Lame's theorem. We know that how to solve this. Equate these two, will get T, and equate these two, will get F. What is the value of F? F, which is equal to 29.999 Newton, which is approximately 30 Newton. And what is the value of T? T, we have to equate these two, right. So T, which is equal to what is the value? 40.005 Newton. So this is the final answer. F, which is equal to 30 Newton. Find the tension and find the tension in the string at this point. So tension, which is equal to 40.005 Newton. Clear? It's a very simple problem. A bullet at the rate of 300 meter per second is fired into a log of wood. The bullet penetrates to the depth of 40 centimeter. If the bullet moving with the same velocity is fired into a similar piece of wood 22 centimeter thick, with what velocity it would emerge? Take the resistance of the wood to be uniform in both cases. So case 1, case 2. So this is case 1. So case 1, the initial velocity, which is equal to, so initial velocity u, which is equal to, the bullet travels at the rate of 300 meter per second. So initial velocity u, which is equal to 300 meter per second, and the what is the final velocity? So the bullet penetrates to the depth of 40 centimeters. So after penetrate, the final velocity, which is equal to 0, right, which is equal to 0 meter per second squared, right. So distance traveled, which is 40 centimeter, right. The distance covered, which is S, which is equal to 40 centimeter, which is equal to 0.4 meter. Now we know that v squared minus u squared, which is equal to 2as, right. So v, which is equal to 0. So this term became 0, right. Now u squared, what is the value of u squared? U squared, which is equal to minus 300 squared, which is equal to 2 into a into s, which is equal to 0.4. Now what is the value of a? A, which is equal to 112500 meter per second squared. This is velocity meter per second, uniform velocity, this is meter per second, not second squared, right. So acceleration, which is equal to meter per second squared, right. Now case 2. Now case 2. If the bullet moving with the same velocity is fired into the similar piece of wood 22 centimeter thick, with what velocity it would emerge, right. So after penetrating, the acceleration is converted into retardation, right. So now S, which is equal to the given 22 centimeter, the bullet travelled at 22 centimeter, which is equal to how much? 0.22 meter, and acceleration which is equal to in terms of minus of the same 112500, because take the resistance of the wood to be uniform in both cases. So, A which is equal to meter per second square. Now, we have to find velocity of the bullet, final velocity, right. So, same formula v squared minus u squared which is equal to 2as, right. So, v squared minus u squared which is equal to 300, which is equal to 2 into A which is equal to minus of 112500 into S which is equal to 0.22 meter, right. So, v squared which is equal to what is the final value? Solve this 300 squared into 2 into this is in terms of minus. So, minus minus cancel C which is v which is equal to 201.24 meter per second, right. This is v which is equal to 201.24 meter per second. This is the final answer, right. So, if the bullet moving with the same velocity is fired into the similar piece of wood 22 centimeter, then the velocity of the bullet which is equal to 201.24 meter per second. Okay. Thank you.